When a football moves across the pitch, it translates. When it bounces off a wall, it reflects. When it spins, it rotates. Today we explore transformations using matrices. An isometry is a transformation that keeps size and shape unchanged. Translation slides, reflection flips, rotation turns. Enlargement changes size using a scale factor. The identity matrix keeps a shape unchanged. It's like multiplying by 1. Any point times this matrix stays where it is. This matrix reflects across the x-axis. The x-coordinate stays the same, but y becomes negative. Notice the -1 in the bottom right position. Let's reflect point 3, 2. We multiply the reflection matrix by the column vector. Top row, 1 times 3 plus 0 times 2 equals 3. Bottom row, 0 times 3 plus -1 times 2 equals -2. The image is 3, -2. See how it flipped below the x-axis. For 90-degree anti-clockwise rotation, we use this matrix. Multiply. Top row gives 0 times 2 plus -1 times 0 equals 0. Bottom row, 1 times 2 plus 0 equals 2. The image is 0, 2. The point rotated from the positive x-axis to the positive y-axis. Common exam mistake. Students write coordinates as row vectors. Always use column vectors for matrix multiplication. Rows don't work with transformation matrices. Memory aid. Column vectors for coordinates. Matrix times column vector gives new position. Always sketch to check your answer is reasonable. Subscribe to Ovasaabi for more mathematics lessons. Visit ovasaabi.com to practice past paper questions and master your exams.